Hey guys, Buildzoid here, and today we're going to be taking a look at another DDR5 overclock with Ryzen 9000. Today we're going to be taking a look at a 2x32GB setup on the MSI X870 Tomahawk. The motherboard was provided by MSI, so big thank you to them for sending it over for testing. And the CPU that I'm using is a Ryzen 9 9950X, which I bought, so a big thank you to the channel supporters for funding the purchase of the CPU. And the memory kit that I'm using is a Silicon Power Zenith 2x32GB DDR5-6000 CL30 kit, which I also bought. So a big thank you to the channel supporters for funding the purchase of the memory kit. If you'd like to support the channel, there are links in the description that you could check out. That would be very much appreciated. And with that out of the way, let's get into it. So, this Silicon Power Zenith 2x32GB DDR5-6000 CL30 kit is based on Hynix 16GB A-die memory chips. Now, and it's in a dual rank configuration because 2x32GB with like 32GB DIMMs using 16GB memory chips, it has to be dual rank. Now, I know that this is A-die, not because of like the label on the memory sticks or anything like that, though I do kind of suspect that the A in the part number of these memory sticks might actually be related to these being A-die, but I'm not 100% certain about that. Because yeah, it could just be a random letter A in the part number. The reason I'm certain that these are A-die is because if you look at the memory timings that I've been able to get working on these, you'll notice that the TRFC is 400 at DDR5-6400. And if this was M-die, this would not even post at this speed. So like that TRFC at this speed would not even post. Also, I can run lower TRP than 36 on this memory kit. It's not stable at that point, but if this was M-die, it wouldn't even post with like a TRP of 32. You wouldn't be getting into Windows. So the fact that like it crashes stress tests at 32 isn't really like, that's not great, but it already confirms that this is most definitely not 16 gigabit M-die. This has to be 16 gigabit A-die. So that's what this is. Now, how did I end up with this memory kit? Because Silicon Power is to me, it is not a name brand of memory, if you will, right? Like, how did I end up testing this? Well, that's very simple. I went to PC Part Picker, and I did the following. Because I wanted to test more dual rank DDR5 kits, so I just went 2x32 gigs, and then, like I've been saying for a while, that look, if you want good RAM, but you don't want anything super special, you should just buy 6000 CL30, right? Like, just 6000 CL30, and then buy the cheapest thing that you can find. And so that's exactly what I did, is DDR5 6000 CL30, 2x30, 2x32, and then lowest price. Now, at the time when I was buying this memory kit, this was not available at this price. I think it was like slightly more expensive. I was also considering the Kingston kit, because that's almost the same price as this Silicon Power kit. But the thing is, I've tested Kingston kits before, admittedly only single rank ones, but like I've tested others Kingston kits, and I wanted to get some more variety in terms of the memory brands that I've tested. Not that I expect there to be much of a difference. Like, I'm assuming, like, some memory manufacturers will actually have custom PCBs, but a lot of the sort of like budget memory kits, I'm assuming they just use the JEDEC standard PCB layout. So they should all be the same regardless of who actually makes them. They very well could actually be buying PCBs from like the same PCB manufacturer with the same PCB design, and that just slapping their own heat spreaders on top of it. For some of these like smaller memory manufacturers, though, I'm not, like, the funny thing is, like, sometimes there's brands where it's like, oh, this isn't like a super mainstream brand, but that's like, it's not super mainstream in like Europe and the US. That doesn't mean it might not be huge in Asia, right? So I don't know, but Silicon Power to me is kind of a no-name brand for memory sticks. So that was one of the other reasons I wanted to test this, because I've tested Patriot kits, I've tested Kingston kits, Corsair kits. I haven't tested Silicon Power, and it was one of the cheapest options. So that's how I ended up with this. Just basically buying just the cheapest 6000 CL30 kit that I could find in the capacity that I wanted. And are there downsides to that? Yes. And that downside is the heat spreaders. These heat spreaders massively suck. Like, hugely suck. These are terrible. The so you can't, well, you can't see it here, but in the photo, these actually have like a stamped like curve into the heat spreader, and that curve, like this part of the curve over here, starts roughly where one of the memory chips is. So that memory chip doesn't get very good contact with the thermal pad, or well, the thermal tape. It's not even a thermal pad, but like the thermal tape doesn't really make very good contact with that memory chip. Same is true actually for the memory chip on the very outer edge. That one also isn't getting very good coverage with the thermal tape, though that one doesn't have the heat spreader literally trying to lift off of it. There's no thermal pad for the voltage regulator, which I find really surprising because I thought the whole reason this portion of the heat spreader is like indented inwards was to like minimize the gap between the heat spreader and the voltage regulator, but nope, that's just for aesthetic purposes. It serves like there's no thermal pad under that, so it doesn't serve any functional purpose. Yeah, so these heat spreaders, terrible. And without the fan, these memory sticks very, very quickly end up at like 70 degrees Celsius. So yeah, that's the downside to these. I honestly kind of suspect that these would probably run cooler with the heat spreaders removed. And so that is something I might test. The other thing I kind of want to test is what kind of settings these max out at if I'm not using the fan. Because the fan, like, dual rank DDR5 does run hot, but in the grand scheme of like heat outputs, memory sticks really don't, like even hot running memory sticks don't actually produce that much heat. The problem is that they don't have proper heat sinks, right? So if you point a fan at them, even if the heat spreaders are terrible and they're dual rank DDR5 sticks, they actually don't run that hot. And it's not like this fan is some like super fast, high airflow monstrosity. So yeah, throughout testing, these memory sticks actually just maxed out at, you know, just under 50 degrees Celsius, which is a perfectly good operating temperature. Like, that really doesn't cause any issues. I was able to stress test with a refresh interval of 65,000. So, like, as much as I'm complaining about these heat spreaders being miserable, if you just point a fan at them, that kind of completely negates the issue of the heat spreaders being miserable. Because, yeah, like, airflow is overpowered for cooling. Imagine that. So, but yeah, without the fan, these get very, very hot. And so that is something I want to mess around with, is just like see what kind of settings these sticks could run if there wasn't a fan. Because I suspect it would, like, these probably run hot enough that it's going to hurt even like primary timings, which is not something you usually like consider. But that is actually a thing. Like, you can normally run lower cast latency at lower memory temperatures. You can normally run slightly lower TRCD at lower memory temperatures. Same for TRP. TRAS, I'm not sure about that one. That's just that timing is just weird. I don't think the TRRDs will be affected, but yeah, so there might be some other TRFC might be affected. And so yeah, that's like my main complaint for this memory kit is just the heat spreaders. They're really bad. I might actually experiment with like seeing if the memory sticks run cooler if I remove them as well. But I'm not really in a hurry to do that because, again, like the fan does kind of solve the heat spreader issues. So anyway, so that's how I ended up with this memory kit. I don't think it was like, honestly, I still think, you know, the whole like buy the cheapest 6000 CL30 kit, I still think that holds true. Just like, yeah, if you get one with really bad heat spreaders, point a fan at it. Though even if you get a memory kit with good heat spreaders, if you're going to be pushing the memory sticks, you should probably still point a fan at them anyway, especially if they're dual rank, because yeah, dual rank DDR5 sticks do run really hot, even when they don't have terrible heat spreaders. So, yeah, anyway, in terms of stress tests that I've run, 20 hours of Prime 95, because this is another one of those dual rank DDR5 kits where like TRP really hates getting low. So I kept running into issues like early on in testing, I kept trying to run like TRP 34 with this memory kit. And it would basically cause Prime 95 to error out in like 7 hours-ish. Like sometimes it would happen a bit sooner than that, but typically it would be around the 7-hour mark, which was really frustrating. Like that's taking forever to get that error. Another interesting thing is this is like I have one other dual rank kit of 2x32GB, and that one also did this. It hates really low TRAS. Like if I set the TRAS to 30, Prime 95 is going to error out in like a couple minutes. So that's really interesting because on single rank kits, usually you can, especially with 16 gigabit ADI, you can set TRAS to 30 and it doesn't cause any issues. With dual rank, yeah, that causes massive problems. So that's really interesting to me. So I do kind of want to do some more testing on that with this kit, as well as probably retest the other dual rank kit that I will have, because previously I only tested that kit with the 7000 series CPU, and the 7000 series chips that I have max out at like DDR5-6200. So I'd like to retest with a CPU that can actually run DDR5-6400 in 1-to-1. Yeah, so 20 hours of Prime 95, also an entire day of Karhu, which was mostly, like, that was kind of me procrastinating. Also, I like to tell myself that I ran the stress test longer because it's like a 64 gig kit, but alternatively, I was putting off recording the video, so, yeah. And then, of course, also 3 hours of Y-Cruncher, like, just under 3 hours of Y-Cruncher, to check that everything is stable. So, yeah. Also, one thing I should point out with using Y-Cruncher VT3 for testing, if you have the memory usage really high, the run-to-run variance is going to be really big. So when this ran, it was using, I think, 54 gigs of memory out of 64 gigs of memory. And so that's like key to keeping the variance down. Because if you use like, if Y-Cruncher tries to use like 60 gigs of memory on a 64 gig system, Windows is going to get really upset that there's an application hogging all of the RAM, and they're going to fight each other, and that causes the test speed to go all over the place. So that's something to keep in mind if you're like trying to push the Infinity Fabric to its limits, and you're using Y-Cruncher to check if like the Infinity Fabric is like starting to fail. You can't have Y-Cruncher trying to hog all the memory because Windows is gonna like start fighting with it. So that's something to keep in mind. Other than that, no errors detected by hardware info, and that's been open the entire time that I was running this stress test, which you can also see that, yeah, there was more procrastination happening even after Karhu finished. If you add up all of the runtime here, I think this only adds up to like 2 days, but that's a lot more than 2 days. Anyway, other than that, Nitro Settings, you can see I'm at 131, and I do have the PHY RDLs synchronized. So 36 on both memory channels. Yeah, I think that's everything I want to show in Windows. Also, the 9950, well, one of the reasons I went with the 9950X for this testing, well, there's sort of two reasons. One, the 9950X is the best CPU I have for 1-to-1 mode, as in it runs 3200 UCLK the best out of all of the CPUs that I have. And two, it's a dual CCD chip, so it actually puts more load on the memory sticks. So what's kind of funny is if I tested this memory kit with, say, the 9800X 3D or the 9700X, it would actually end up running somewhat cooler just because there's less write bandwidth on those CPUs than there is on the 9950X. So, arguably, if you had a lower CCD count CPU, the fact that these heat spreaders are so bad would be even less of a problem. But yeah, that is something I do kind of want to experiment with, because that is definitely a thing. And it's also worth noting that even the 9950X compared to an Intel CPU is still not going to put as much stress on the memory sticks as an Intel chip is, because even the 9950X compared to an Intel CPU is very memory bandwidth limited, whereas Intel CPUs, like, I honestly wouldn't be surprised if these memory sticks were another like 10 degrees hotter with an Intel chip, even at like the same settings. Yeah, so that's kind of something to keep in mind, though the higher temperatures with Intel CPUs obviously aren't very relevant if you're buying a Ryzen chip, because those aren't Intel CPUs. So anyway, now let's go into the BIOS and take a look at what I did there. Which is not very much, because the X870 Tomahawk is like very good on auto settings in my experience so far. Especially in 1-to-1 mode, it really like just kind of works. Also, as you can see, I do have memory context restore enabled. because it didn't just spend forever on the 15 post code. And we're back in the BIOS. So, I don't have the latency killer enabled because that just hurts performance in everything that isn't IDA. Then UCLK equals MCLK, 2133 FCLK, because that's 3 to 2 of, that's 2/3 of 3200. And there is a slight performance benefit of running the FCLK at 2/3 of the UCLK. Alternatively, like 2200 FCLK could have a slight performance advantage in some scenarios, but verifying stability of high FCLK is really annoying, so I prefer not bothering with that, generally speaking. The other thing is that pushing the FCLK as high as it goes in most scenarios on Ryzen doesn't really make much of a difference in terms of performance. So, yeah. Anyway, so 6400. Anything else? Nope, nothing there. SoC voltage is in AMD overclocking mode with the SoC voltage set to 1.22 volts. I've not done anything to the load lines because there's no reason to do that for like memory overclocking. DRAM voltage at 1.43, VDDQ at 1.35, and VDDIO at 1.35. I'm not entirely certain that the 1.43 VDD is actually necessary for the settings that I'm running here. Because, yeah, like I mentioned earlier, one of my big mistakes with this memory kit was like trying to get it to run TRP34 for a very long time. Like I spent probably a day or two just trying to get TRP34 to work. As part of that, I tried more voltage. That didn't help. So now we're at TRP36, but I never bothered to lower the voltage again. So here we are. With the dual rank kit, like the thing is, I do have a fan on it. So like on one hand, it's like, would lowering the voltage make the memory sticks run a bit cooler? Yes, but they're already below 50 degrees Celsius, so I don't really see a point in doing that. If they were getting really hot, then maybe it would make sense to try get the lower voltage down, but they're under 50. So yeah, I don't really see a point with bothering to lower the VDD voltage. Now, VDDQ and VDDIO are both at 1.35 volts. And the reason for that is that that's actually the default voltage for this memory kit at 6000. And also, well, I did briefly have both of these set to 1.4. Again, as part of like trying to get TRP stuff to work. And yeah, that didn't help. And so then I lowered them because both VDDQ and VDDIO, these don't really, or they shouldn't affect the memory timings. So when yeah, like I didn't really see a reason to keep them up at 1.4 volts because the memory kit was working at 1.35, and at some point I tried 1.4 and it like didn't help anything, so I put it back down to 1.35 to try slightly reduce the memory temperatures. Actually, this is one thing I wonder about, but I haven't tested this, but VDDQ is the power supply for the actual I/O circuitry of the memory chip. And I kind of suspect that VDDQ is probably more important for memory chip temperatures than VDD. I could be wrong about that, but I have a sneaking suspicion that the I/O circuitry is actually more power hungry than the entire rest of the memory chip. Yeah, because that's the part of the memory chip that actually runs at very high frequencies. The rest of it doesn't run at high clocks. Anyway, so yeah, that's kind of what I did with the voltages. I like, you know, there's not really. So this isn't minimized or anything. Like maybe even lower VDDQ would work, but I don't really see a point in trying to push VDDQ and VDDIO down. And also VDDIO is set to the same value as VDDQ because this isn't always true, but as a general rule of thumb, I like to set both of the CPU I/O voltage and the memory I/O voltage to the same thing, which will make, like, I'll have a video that'll hopefully clarify that at some point in the future as to why I do that. It's not like a hard set rule that this is always optimal, but it's usually a good starting point to have both of them set to the same thing. On some motherboards, you'll find that in certain scenarios, having one of them higher than the other tends to help, but as like a starting point, having them both set to the same thing kind of tends to work pretty well. Anyway, VDDP, I did manually set that to 0.95. I do believe I tested up to like 1.05 or something, because I was trying to run the Nitro settings at 1 to 1, and wasn't really having much success with that. And yeah, I think I tried raising VDDP to get that stable, and that didn't really help, so then I put it back down to 0.95 and set the Nitro settings to 131. Anyway, let's take a look at the memory timings. So, cast latency at 30, TRC DWR at 16, because we don't, like for TRC DWR, you can just set it really low due to how that timing works. TRC DRD at 38. This isn't minimized, but at 6400, it probably won't go any lower than this. Well, if you get lucky, sometimes memory kits will run it at 37, but yeah, I didn't bother to test, and it also wouldn't really make much of a difference in terms of performance to go from 38 to 37. RP at 36, TRAS at 40, TRC at 76. Lowering TRAS on this will actually destabilize the memory kit, so this is... It's not, like, I didn't, like, test TRAS 38, but 30 definitely doesn't work. And I did also try things like, I think, TRP 34 with a TRAS of, like, 50. And that unfortunately also didn't fix the TRP stability, so yeah. Which, if that did work, that would have been better from a performance perspective, because TRP is a timing that gets used very frequently by the memory controller, whereas TRAS is like a very specific, like one scenario only timing. So, like, sacrificing TRAS for TRP is generally a good idea, if it's necessary. It's like, it doesn't always help, but if you have with some memory kits, like raising TRAS to get lower TRP can work, and if that is a thing that works for you, then you should do that, because TRP takes priority, like, is more important than TRAS from a performance perspective. TRC, I just set it to TRAS plus TRP, so 76. TWR at 48, because that's as low as it goes. If you try to set it any lower, it switches over to auto, because that's the register limit. TRFC1 at 400, which this isn't completely minimized, but this is pretty close to as low as it's going to get at 6400 for 16 gigabit Hynix A die. TRFC2 at 480, because it doesn't do anything, and TRFC same bank at 390, because it also doesn't do anything. They're both on auto. Refresh interval at 65,000, so that's completely maxed out. If the memory sticks were running significantly hotter than they are right now, potentially TREFI like 50,000 or lower would be necessary instead of 65,000. RTP12, I didn't bother to check if lower values could work, but maybe they would. But trying to push this much lower, I don't really see a point. TRDL and S at 4, TFAW at 20, because, I mean, I don't think this motherboard enforces... Yeah, this motherboard doesn't enforce the TFAW 20 limit, but as far as I know, that should actually be a limit for AMD memory controllers. Anyway, then WTRL and WTRS at 14 and 4, and then read-to-read SCL4, read-to-read SC1, read-to-read same DIM and different DIM. So these are the dual rank timings. Those are both set to 6. Lowering these any further causes the system to not post. And then the write-to-write, I have write-to-write SCL at 4, write-to-write same SC at 1, and then these two are at 8, though I didn't check if 6 would work. So it might, but in the past testing, like with dual rank kits, I haven't had success running below 8 on these. So, and when I started testing this memory kit, I was really hoping that, oh, this would be like a nice quick, it would, you know, I'd get it done in like a day. And then I spent a ton of time dealing with TRP stability issues, so yeah. Anyway, I do also want to try testing this kit at higher voltages. I don't know if the PMIC on this is actually supports high voltage mode, but if it does support high voltage mode, I do want to experiment with what I want to see like what would be possible with this kit at say 1.6 volts or something. Anyway, WRD at 4 and RDWR at 16, which is just pretty typical stuff for Hynix A die setups, regardless of if they're single rank or dual rank. Gear down mode is enabled for this setup. The justification, I didn't test if disabling it would work. My assumption is it wouldn't, because the point of gear down mode is it basically helps with stability on the command address bus. And this is a dual rank setup, so there's significantly more load on the command address bus than in a single rank setup. And so I don't, want to take my chances with like trying to disable gear down mode for a dual rank setup. It might work, but I didn't test that. It also isn't really going to drastically change performance, so that's the other reason why I don't really see a lot of point in trying to test that. Anyway, then if we scroll all the way to here, I switched the read pointer initial value to 2. And the reason I had to do this is because by default this would be going to 3 if this was on auto. Like this defaults to 3 when you're at DDR5-6400, and that causes the PHY RDL timings to desynchronize. So I showed how in Zen timings both of my channels were T-PHY RDL at 36. If this was at 3, it would actually train 36 and 38 on one of the two channels. So yeah, 2 is necessary for this to synchronize the PHY RDLs for both memory channels. And you want to do this because this gives you a slight memory latency improvement if both of the channels have the same PHY RDL timing. So yeah, that's what's going on with that. Now, onto the Nitro settings, which are unfortunately buried in the Advanced tab under AMD Overclocking and DDR Infinity Fabric options, DDR options, and then here we just have, well, not the robust training mode, but Nitro mode enabled, and then Nitro RX1 3 with TX out 3 and control line at 1. I did try 1-2-1, but yeah, that doesn't work with this setup. I'm relatively certain that this CPU on single rank setups can run 1-2-1. So that's something I might have to like recheck, because I'm pretty sure, either check like past videos. It could also be like a BIOS version thing where like this BIOS doesn't like TX at 2. But I kind of suspect that it's actually related to this being a dual rank setup. And that putting like more stress on the memory controller, because the Nitro RX-TX control line timings, these are internal timings to the I/O die, so they're between the PHY and the memory controller, and I think the extra load on the memory controller from this being a dual rank setup is like actually affecting the Nitro timings. That's at least my theory, because the alternative is that I just forgot that the CPU doesn't do 1-2-1, which is also possible. But I'm relatively certain that the CPU did 1-2-1 at 6400 with single rank. So yeah. Anyway, and that's it. So yeah. Like this silicon power memory kit, the heat spreaders are terrible, but hey, if you point a fan at it, it's still, I mean, I'm not sure if they're all going to be Hynix 16 gigabit A die, right? Like, I really don't know. But this one definitely is 16 gigabit A die. If it was M die, then honestly, it probably wouldn't make, like, in 1-to-1 mode, it wouldn't really make too much of a difference. You'd just not be able to run as low TRFC, and TRP instead of 36, you'd be looking at 38, which really isn't the end of the world in terms of performance. Yeah, so I don't know for sure that every single one of these silicon power memory kits is actually going to be A die, but this one was A die, and really the only complaint I have for it is just the heat spreaders are kind of terrible. But as far as like overclocking this, it's just dual rank A die. It even does the thing that my other dual rank A die kit does, where it like hates low TRP and hates low TRAS. So, that's that. So yeah, that whole like just buy the cheapest 6000 CL30 kit in the capacity that you want, I'd say holds true. At least with this kit, definitely holds true. Just need to point potentially you might have to point a fan at the kit. But yeah, fans are also cheap. Like the funny thing is, you're probably better off pointing a fan at a really cheap DDR5 kit with bad heat spreaders than trying to buy a kit with like good heat spreaders. Because unfortunately, the physical form factor of memory sticks does not lend itself to big heat sinks very well, right? Like, there's just not really that much space for a large heatsink. So you really are better off just pointing a fan at like bad heat spreaders rather than trying to find a memory kit that has heat spreaders so big that you could run it completely passive, especially for dual rank. For single rank, you might be able to find something, but dual rank, I doubt it. So yeah. Anyway, that's it for the video. Thanks for watching. Hopefully you found this somewhat interesting, if not particularly useful. Big thank you to the channel supporters for funding the purchase of the CPU and the memory kit. If you'd like to support the channel, there are links in the description, so if you check them out, that would be very much appreciated. And also, thank you to MSI for the motherboard. And with that, that's it for the video. So thanks for watching, and goodbye.